Hi everyone, and welcome to our channel specialized in designing MATLAB applications. In this video we are going to show you a very beautiful app that makes the regression process through support vector machine SVM just a fun. Let's run the app to explore it in more details. As can be seen here, the app itself is called SVM EasyTrainer, which emphasizes our allegation regarding its usefulness. As can be clearly seen, we can select the target from any column. For example, this is just an arbitrary dataset. We can select, for example, this is our target or response. We can select this one, we can select this one. Can you see the headers? They will change automatically. We can import our dataset from any standard format like .xls, .xlsx, and .csv files. For example, from here we can see these formats. We can see them here. All these formats are accepted. So from here we can come to datasets. We can select, for example, all files, all file formats. We can see, for example, here we can select this one, student performance reduced. Okay, because we want to decrease the time because it has lots of entries or lots of rows. This dataset is taken from this website, Kaggle, and from this repository. So we have this dataset, and we can select the target, which is the last column, and now we can come here. Do we want to split the dataset into train and test sets? If we want, then yes. If we don't want, then just no. So okay, we want it because we want to overcome the overfitting phenomenon. Then do we want to use MSE, MAE, mean absolute error, or root mean squared error? So okay, we are happy with MSE. Do we want to reproduce a train test split? Because every time we run, we will get random vectors of train and test subsets. So if we want to reproduce the data, this is very useful for comparison studies. Then we can take this checkbox. Okay. For kernel function, we can also select different kernel functions here. And we can also, for polynomial, we can also increase the order till 20. So this is, for example, linear, and this is Gaussian. And for solver, we can also select these types: SMO, sequential minimal optimization, ISDA, or L1QB algorithm. Also, do we want to standardize data? We can select false or true. Okay, so let's use, for example, linear. Everything's normal, and let's just start. Very easy. And it will get the data. We can see the actual and predicted responses. For example, if we want to just change the shape or style of this plot, then we can, for example, change the background if we want to, for example, black. Here, for example, the grid, we can select this color, for example. Okay, so we are happy with transparency of the grid. Okay, do we want to see the minor grid? We can press on that, or we can disappear it. We can also select the type of grid, or for example, like this. And we can, if we want to increase the width, we can also. But we are happy with 0.5. Okay, for actual response, it is black. So we can change it to, for example, cyan. Okay, and we can also put markers, square, for example, and this square, we can change that one also to this color, and marker size can be also increased. decrease it a little bit. And we can also change the marker edge color to, for example, this color. Okay, so we have lots of things. Here, for example, for the predicted response, we can select this one. So we can define the plot in different styles. If we are happy with this plot, then we can export it outside. So we can export it, and we can also what? We can save it for using it in other things. For example, in posts, in MS Word, in LaTeX, in, for example, magazines, journal papers, in books, lots of things. Okay, if we are happy with this data and we want to export it, can we? Yes, we can export all these things by pressing on this one. And we can say, for example, results, save it to XLS, okay, we can save it. We can come here and we can open it. And we can see all these data. This is for the full set, this is for the test subset, and this is for the train subset. If we want to replicate the results, then we can also do that. We can come here and we can export the model to, for example, let's say, let's come here, output, and from here we can select, for example, SVM model. Now, if we come to this folder, we can see two files, the model, and we have also a M file. If we open it, then we can see this one. It says that it can load this SVM model that has been created, but we need to define our input. It can be xtest or xtrain or any value from our side. But if we want to replicate the data, then we can take this xtest. We can come here to test and we can take this x. Okay, so this is our value. We can put any value from our side because it will be estimated by SVM. So here we can write x test equals, and we can put that one. Okay, so this is our value, and we can just run it. So we can see the response here. If we open it, we can take it. We can just press that one, Control C, and we can come here and paste it. For example, let's come here, or let's increase it. Oh, for these, let's decrease them to this, and for these, like this. And here we can just say from command line or command window, and we can paste it. Can you see the same values can be replicated again? So the SVM model can be saved, the plot can be saved, the data can be saved. Okay, if we want to change, for example, our settings, for example, here MSE is 4.37. If we want to enhance it more, can we? Let's try. Let's select polynomial and let's see its performance. It is 4.3138, and now let's see the performance. So it is bad, 6861. So let's select true. Let's run it. It is now 4.6 instead of 4.3. Let's increase the order to 4.7. Let's increase it to 5. It is increasing, so let's check order 2 or second order. So it is 4.3. And now let's take, for example, Gaussian. It is 11. And with ISDA, for example, is 10. What about polynomial? 4.3 linear. So it is 15.6321. Let's check polynomial. So it is 8. So the best one was for this case is linear with false. It's 22 because it was the first algorithm. Let's check the third one. 4.36, and the first one. So the best one is this combinations. What about the true? So that one. This is very good results, and we can stop here. So as can be seen, this program gives you the power to perform SVM analysis quickly and very easily. It is highly user-friendly application, and you can use it without any programming skill. At the end, you can download the entire project if you would like, or just the MATLAB app installer from the links provided below in the description. Thank you so much for watching, and don't forget to subscribe to see more MATLAB apps. Goodbye.